Okay, so in order to complete this activity, you need 5 large styrofoam balls to use as the middle elements, at least 10 small styrofoam balls, some popsicle sticks, and note cards with Lewis structures to draw on them. You also might need some pins to draw the Lewis structures and pins to punch holes in this large styrofoam balls. Okay, so today we're going to do a summative Lewis structures assessment just to make sure that you're definitely grasping the concept of Lewis structures because it's so important in Chem 105. The first thing that you're going to do is pull a card from the stack of possible Lewis structures for you to construct.
I have carbon monoxide.
Okay, so from that card you're going to draw the Lewis structure of that compound.
Carbon has 4 valence electrons, while oxygen has 6. And 2 lone pairs on each side.
Good job. So from the drawing that you have created, create a model of the molecular geometry of the compound where the large ball is the central atom and the smaller balls are the outer atoms. But since this compound is linear, you can use both of the big balls if you would like. That's why we have more popsicle sticks.
Great. It's linear.
Okay, and you've already named the molecular geometry, so can you estimate the bond angles for the carbon and for the oxygen?
Alrighty then. Carbon monoxide has a linear bond of 180.
Okay. And just for the 5th instruction, we have to create another model. So just repeat steps 1 through 4 again so that you can make another one.
Now I have carbon with 4 H's, which is also called methane.
And how many valence electrons does carbon have?
Carbon has 4.
Making sure that we have productive downs, productive plays, and don't get too far down the chain. When you get those guys loose, go back.
While hydrogen has 2.
They find 7 minutes later, that much time to get the ball.
So why did you decide that it was tetrahedral instead of something like triagonal planar?
Because there's 4 bonds and each bond is completed with another element involved. So each carbon has 4 valence electrons and there's 4 hydrogens, so each one will have a bond with one another.
I think it's too good for both teams playing each other. I think it's good defense playing.
Very good explanation.
So this is all about.
There might be a little bit of an understatement there. This is strength versus strength. Broncos averaging an NFL high 41 points a game. Denver also
And my tetrahedral model is complete.
Okay, so what are the bond angles?
This bond angle is 109.5.
Okay, so the last step is once you have completed two compounds, compare and contrast the two structures that you have created.
Alright, again, tetrahedral has bonds of 109.5, and the carbon monoxide has a bond angle of 180. And you can clearly see how each one of these are equally separated by each other, and this is just one central bond.
Okay. And in order to make this activity more difficult, you can make the note cards have different, be in different electron domains. So they can be like triagonal bipyramidal, they can be triagonal pyramidal, or something in octahedral. You can make it something for naming and just help them to memorize their polyatomic ions. So you could do something like draw a Lewis structure for ammonium, or draw a Lewis structure for carbonate. And then another thing that you can do to take it a little step further is to ask your tutor to determine whether or not the structure is polar or not.